Hello children, so the topic is lens maker formula, very important derivation from ray optics. So what is the lens maker formula? It's a formula between refractive index of the material of glass and its two radii of curvature, radii of curvature 1 and radii of curvature 2. It's a mathematical relation between these three quantities. This formula relates focal length, refractive index and radii of curvature of its two surfaces. So this is called lens maker formula because it is used by the manufacturer to design lenses of required focal length. Okay, there are certain assumptions to be kept in mind while deriving. The lens should be thin, aperture should be small, object should be point object, and the rays should be paraxial. So first we are deriving lens maker formula for a convex lens. So this type of diagram you would keep ready. This is object. O is the object. You will write O is object. Object distance you can take it as U. Okay, so this ray will go and here the medium will change. This is your first surface A, B and C. Right? So this surface will bend it and will make the image here. So this is my image formed by first surface. So I1 is image formed by first surface. Okay, image distance you can say as image distance we will take as V1. And what is the refracting surface here? ABC, first surface is refracting surface. Okay, and the first surface radius of curvature is R1. Okay, so we will use the formula for refraction now. It is use formula for refraction using formula for refraction from rarer to denser. This is rarer and you are going towards denser. You are hitting against first surface, right? From rarer to denser. Then in the previous topic we have done 6 cases and we know the formula. What is the formula? It's mu2 by image distance. We will write like this, not in form of symbols. Minus mu1 by object's distance is equal to mu2 minus mu1 by radius of curvature. So let us substitute the values. You can see image distance we took it as V1, object distance as U, and it's mu2 minus mu1. First surface was involved, so it's R1. This is my first equation. After this, wait, I will draw the diagram once again. Like this is the diagram. Okay, how much diagram is ready already? So this much diagram is ready. This was object. It was A, B and C. This much diagram is ready. This was the first image. I1. Now this I1 will act as object. I1 is object for second surface. And what is second surface? ADC. ठीक है, object distance. Again, listen. I1 is object for second surface. But for first surface, this is the image. So image distance in previous case was V1. So here that V1 will act as object distance. Now second surface will refract the ray finally and it will form the image here. This is final image. Image for second surface is the final image. So your final image is I. Final image is I and final image distance is V. Now we will use formula for refraction again, but this time because we are hitting against second surface, so we are going from denser to rarer. So we'll use that formula. So using formula for refraction, from denser to rarer surface, what will we get? We will get it as the formula we know, mu1 by image distance minus mu2 by object distance is equal to mu1 plus mu2 by radius of curvature. So let us substitute the values. So you can see image distance is V, object distance is V. So let us substitute. Let us substitute mu1 by minus mu2 by V1 is equal to mu1 minus mu2. Here the refraction is taking place at second surface, so it is R2. And this is my second equation. Now I'll write my third equation as well, which I remember. It's mu2, because that was a formula for rarer to denser, so I remember mu2. And the object in second case was image in first case. And here it was mu1, object was u, and it is mu2 minus mu1 by r1. This is my first equation. Now we will add up the two equations. When we add up, we see this term and this term are same and with opposite sign, so they'll cancel out. We'll write first term as it is, then second term, this one, then that right hand side, plus right hand side of first equation. So now we can take from here, we are taking like, let it be, we are taking here mu1, it is 1 by v minus 1 by u, and here we have, we will keep this r1 wala term first, mu2 minus mu1 by r1. This term I am keeping later, but negative sign I am taking common, so it will also turn into mu2 by mu1 by r2. R2 is okay. From upper term I have taken negative common. ठीक है, The sign is changed. So now I'll take common. So it's mu2 minus mu1 is common. What is left inside is 1 by r1 minus 1 by r2. It is equal to mu1 1 by v minus 1 by u. So mu1 will come down that side. So 1 by v minus 1 by u is equal to mu2 minus mu1 by mu1 1 by r1 minus 1 by r2. So now this is okay. Now when object is at infinity, when object is at infinity, then image is formed at focus. So let us substitute 1 by f minus 1 by minus infinity is equal to mu2 minus mu1 by mu1 1 by r1 minus 1 by r2. 1 by infinity is 0. So 1 by f comes as mu2 minus mu1 by mu1. Okay, this is 1 by r1 minus 1 by r2. This is called lens maker formula. This formula is lens maker formula. Okay, this can be memorized as 1 by f equals mu2 is glass lens material, mu lens. This is air, mu1 is air, or you can say surrounding. When lens will be dipped in water, surrounding will be water, not air. So it's mu surrounding down also. Okay, mu surrounding can be mu medium. So this is also lens maker formula. Some people learn it in form of glass and air. So you can learn that way too. Mu glass minus mu air upon mu air 1 by r1 minus 1 by r2. This is lens maker formula. You can leave up to here or here or here, but this we have derived with the help of convex surface, convex lens. And now we'll be doing it because in exam it can come by concave lens as well. So let us see by concave lens. So lens maker formula by concave lens. So for that we will draw concave lens. This is principal axis. We can keep the object somewhere. So here is the object. So first ray will go from object. Up to first surface you will draw. Okay. So first surface will diverge it and form the first image. So this is first surface is diverging it. Spread up to here. Then stop. Produce it back. Bilkul straight. I could not draw. You have to draw it straight. This is I1. And first surface is your A, B, C. So same type of labeling you have to do. O is object, A, B, C is refracting surface, I1 is image, Now you can talk about the distances. Object distance is u. Image distance is v1 sorry, first image है ना. So image distance is v1. Case is from rarer to denser, so same formula. So it is mu2 by image distance so mu1 by object distance is equal to mu1 by mu2 minus mu1 by radius of curvature. ठीक है, and radius of curvature will come off first surface. Radius of curvature will be of first surface. ठीक है, so let us substitute mu2 by v1. It is mu1 by u, and it is mu2 minus mu1 by r1. Equation number 1. Now let us do the final touch to the diagram. Now who will be object, who will be the second surface, second reflecting surface? It will be P, Q, R, and who will act as image? This I1. Okay, so what will be object distance? See, let us again discuss. P, Q, R is the second refracting surface. I1 will act as object for second refracting surface. Yani ki this will be object distance. And final image will be formed at I. Let us see. Now this will, second surface will diverge it even more. So produce it back straight, absolutely straight. I couldn't, you will draw it properly. This is final image. ठीक है, तो we can write these things down. Second refracting surface. Second refracting surface is PQR. Who is object? I1. Image I. Object distance V1. Image distance, final image distance V. And case is formula for refraction from denser to rarer. You are striking against this. So you are going from glass to air. That is denser to rarer. So what is the formula? Mu1 by image distance minus mu2 by object distance is equal to mu1 minus mu2 by radius of curvature. Let us substitute the values. Mu1 by image distance is V. This is V1. This is mu2, mu1 minus mu2 by R2. Radius of curvature of second surface, which is like this. Somewhere center will be there. This is R2. So we'll substitute here. This is my second equation. Now rest of the derivation will be same. In fact, full derivation is same, only diagram is different. You will write first equation, you will add them. Like what is first equation? I remember it's mu2 by v1, and here it is mu1 by u is equal to mu2 minus mu1 by r1. So kindly see the first derivation and do the further steps as it is. Okay, only diagram is different, and diagram has to be drawn with utmost care. So let us do practice of diagram once more. Draw a proper concave lens. Draw principal axis. Object first ray up to first surface. Diagram is very important. Derivation is same as that of convex. Now first surface will bend it. So let us diverge it. Okay, so this will be your first image. And now it will diverge it finally. Okay, it will spread it more according to the nature. You see, I cannot do it properly, but you can. Now you produce it straight virtually. So this is the image, final image. So this kind of proper diagram needs to be drawn. So you can see this is properly drawn diagram. This one, okay, it has to be drawn this way. Yes, you can see this diagram. This is good. Objects ray bent by first surface. Okay, so this is I1. Then bent by second surface. This is I. Final image. U, they have denoted by B dash. I denote by V1. So prepare it properly.